In this tutorial we are going step by step on how we can achieve this kind of simulation with 3D object scatter, and explain a bit how the Flex solver works, and give tips on how to work with soft bodies. So let's get started. Okay, so I'm going to launch 3D object scatter. And this is how we start. It automatically creates a monkey head and an instance array tool. So it creates them so the user can become familiar with the software, but you can delete them for now. In this button here, you can toggle on and off the visualization of Flex particles. If you turn it on, you can see the particles, and turning off you can see the mesh of the object. You have here an instance array tool. You can just delete these two objects. Now, for navigate in 3D object scatter, you can navigate in two ways. The first one is like navigation. You press left Alt plus left mouse button and drag for rotating the camera. Left Alt and middle mouse button and drag for panning the camera. Left Alt and right mouse button and drag for zoom in and out the camera. If you select an object, you can press F to frame the camera on that object. You can also do Unreal-like camera navigation. If you hold the right mouse button and drag the mouse, you will rotate the camera, so you can look to any direction. If you press, while holding the right mouse button, if you press A, W, S, and D on your keyboard, you can move the camera in a first-person shooter kind of way. You can move the camera to the left and right sides, and in and out. And that's how you can navigate the scene with 3D object scatter. So, the first thing we are going to do is delete everything in the scene. And then, we are going to import the model of the bust. So go to File and select Import, choose the OBJ file. Since the OBJ model is a heavy model, it's going to take a while to load. And here it is. So, we are going to simulate a soft body with it. Right now, if you go to the simulation settings in the physics menu, the radius of the particles is 0.2, and that's a reasonable size for the scale of the object we have here. So, let's test this. Select the object. Let's go to the physics menu and click on Create Soft Body. Since the model we have here has a lot of polygons, it's going to take a while for Flex to create the physics asset. So, here it is. This is too much soft. It looks like a cloth right now. If we get the Pick Object tool in the tool menu, we can interact with the object. When you create a new asset, the console window shows how much particles the asset have. You can also check the Physics Assets browser on the bottom. And if you hover the mouse over the assets, it shows information, like name, the type of asset, and how many particles it has. Okay. Right now the asset is a little bit too soft, and it looks like a cloth. So what can we do to remedy that? We are going to the Physics menu, and click on the Soft Body settings, on the right side of Create Soft Body option. And in the Soft Body Settings window, we could adjust the cluster stiffness, which controls the stiffness of the soft body. Right now it's on 0.1. But, instead of that, what we are going to do is, go to the Flex Simulation settings, and increase the number of substeps. As you can see, if we increase the number of substeps here, the asset becomes more stiff, more rigid. So what happened here is that, when you increase the number of substeps, in Flex, the number of iterations on the collision detection of the particles is increased, and with it, the number of iterations over the constraint solving is also increased. So the constraints of the asset become stiffer, and that's a characteristic of the Flex solver you want to remember. And now, the asset is very soft, and that's how we want it to be. Not cloth-like, but still very soft. It's pretty great actually. If you turn on the visualization of the particles, here's what we have. Now we are going to test the collisions of the object. Let's spam a few assets by clicking on the asset in the Physics Asset browser. and choosing to instantiate a new asset and see how it goes. And everything seems to behave nicely because we have a high number of substeps too. If you are getting interpenetration issues with the assets, you might want to increase the number of substeps. But if you increase it too much, the simulation can become very slow. And the more assets you have in this scene, the slower it gets, because Flex has to solve all the constraints. But the effect we get is pretty nice. It's also important to notice that Flex works better with closed meshes, like this one. If your model have a hole in it, it can cause problems, especially collision problems. So, it seems we have a problem here. There is some glitch in the mesh. What may have caused this? If we turn on the particles visualization, we can see that there are some particles lying on the ground here. These particles are escaping from the assets and causing that errors on the mesh. So to fix this, we need to recreate this asset again. So let's see how we can fix that. Let's go to the Loaded Models browser on the bottom. And we are going to instantiate the head mesh again. We go to the soft body settings. Now, the reason why the particles are escaping is because we have the cluster radius too low. If we increase it, then the clusters, which are the bones, will get more reach on the particles around them and will cover the whole asset, so no particles can escape the asset. But if we increase the cluster radius too much, the whole asset becomes stiff like a rigid body. So we'll set this to 1.5 and we'll create the soft body again. As you can see now, the soft body is very rigid. Let's decrease the cluster stiffness and see how it goes. So, the model is a little bit softer. But let's see if we can decrease the cluster radius to get a more jelly-like soft body. So, now we get this really nice soft model. We could go softer, but that's pretty much okay. For our purpose, it's really wobbly. Let's create some more and see how it collides. So we are getting interpenetration issues, so we can bump up the substeps to see if that fixes the problem. And increasing the substeps didn't fix the issue. So let's see what else we can do to fix that. So, one technique to fix the collision problems is to have the particle spacing so more particles can be created in the same asset. Sometimes the penetration issues can occur due to particle gaps in the asset, so if you have a thin layer of particles, the penetration is easier to occur. So that's why we have the particle spacing, so we can have more dense assets. Like this. So, now, the models are colliding way better. But it's also slower, because we have many more particles and constraints per asset. So, as you can see, we need to fiddle with the soft body settings, find the sweet spot between the stiffness and substeps in the simulation. To get the look that we want for our assets, you have to set the particle spacing, volume sampling, surface sampling and cluster spacing to half the size of particle radius to get more particles and avoid the collisions interpenetration. But we can get really nice simulations once we got the settings right. So now we can set up the simulation for exporting. Okay, now for the simulation. I'm going to Tools and click on Instance Array tool. This will create an Instance Array tool object for us. Click on it. Now go to the Physics Assets browser at the bottom and click and drag the last asset we created for our simulation. I'm going to drag it and drop it on the asset list here. It automatically creates 9 assets. I'm going to put one in here and create only 3 assets for the sake of this demonstration. You can click here to increase the distance between the objects. Move and position the objects above the floor. Now, I'm going to pause the simulation. And click here on this green button to create the instances. Oops, let's pause it. Now, select all the objects in the simulation. Go to File and click on Export Alembic Animation. Choose the path to save your file. I'm going to name it my animation point ABC. And now it's going to ask us, how many frames do we want to save? For this demonstration I'm going to set it to 500 frames. And click on OK. Now, Flex is going to simulate the soft bodies, and the animation will be saved to the Alembic file. Since Alembic stores animated vertex positions for soft bodies, and we have a high number of polygons in the scene, the file cache will be huge. This is going to take a while to simulate, so I'm going to pause the video and come back when it's done. So, here we are. The simulation has finished. You're gonna see the objects here. And 3D Object Scatter is going to output here in the console how long it took to simulate and save the file. The simulation took 316 seconds. And here, the Alembic file is 9 GB. So, it's a big file, but now you can open that Alembic file on your preferred software and render the animation. So here is the result we get after we render it in Maya and Arnold. But you can render in any software you like. So this concludes this first introduction tutorial for 3D Object Scatter. I hope you enjoyed this video and learned the basics in the workflow, and if you're not familiar with or interested to know more about 3D Object Scatter, access our social media pages and links. They are down here in the description of the video. Thanks a lot, and I'll see you next time.